Hey everyone. Think about everything around you right now. Your home, your phone, your car. It all started deep inside the earth. In this explainer, we're going to dig into the essential building blocks that make our modern world possible. Minerals. Well, the answer, and it might surprise you, is minerals. They are these essential, often invisible ingredients that connect the natural world to our daily lives in thousands of ways. So let's start with the most basic question of all. All right, first up, what is a mineral? Let's get a solid definition for these fundamental components of our planet. So, what exactly makes something a mineral? Well, geologists have a very specific checklist. It's got to be a naturally occurring solid, it needs to have a specific chemical recipe, and it has to have an ordered crystal structure. You know, a great way to think about it is to picture a chocolate chip cookie. The cookie itself is like a rock, but the individual ingredients, the flour, the sugar, the chocolate chips, those are the minerals. Okay, now this is really fascinating. If you could somehow break down the Earth's crust into its most basic elements, you'd find something pretty amazing. Just two elements, oxygen and silicon, make up more than 70% of it. That incredible abundance has a huge impact on the kinds of minerals we find all over the planet. So, because oxygen and silicon are everywhere, it totally makes sense that the biggest and most common mineral family is the silicates. Quartz is a perfect example of that. But of course, there are other really important families too, like the oxides that give us metals like iron, or the carbonates which build entire rocks like limestone and marble. Okay, section 2. Let's talk about how we get from these minerals just being scattered around in a rock to them being concentrated enough for us to actually use. How do they become a resource? You know, when we talk about minerals that we can actually use, we tend to split them into two big buckets. On one side, you've got metallic minerals. We value these for the metals we can pull out of them, like iron from iron ore. And on the other side, you have non-metallic minerals, which we value for what they are, just as is. Think of salt for flavor or gypsum for making drywall. And that brings us to a really, really important term you've got to know: ore. See, an ore isn't just any old rock with some cool minerals in it. It's a deposit where a valuable mineral is concentrated enough that it can be mined profitably. This is a purely economic definition. A chunk of rock that's worthless today could become a valuable ore deposit tomorrow if the price of that mineral goes up. So, how does nature cook up these valuable ore deposits? Well, there are a few main recipes it uses. You can have hot, mineral-rich water flowing through cracks in rock, creating hydrothermal deposits. Or, as magma cools, heavy minerals can settle out, forming magmatic deposits. Even something as simple as a river can do the work by concentrating heavy minerals like gold into what we call placer deposits. All right, so once geologists find one of these ore deposits, the next step is a huge one: actually getting it out of the ground. Let's move on to section 3, mining our planet. Basically, there are two main ways to go about it: surface mining and subsurface mining. And as you can see, each has its own big set of trade-offs. Surface mining is for deposits near the surface. It's usually cheaper and more efficient, but it can cause major disturbances to the landscape. Subsurface or underground mining goes after the deep stuff. It's way more expensive and dangerous, but the impact on the surface is a lot smaller. Let's look at a surface method first. Open pit mining is, well, pretty much exactly what it sounds like. We're talking about digging a gigantic, terraced hole in the ground to get at these huge, shallow ore bodies. This is how we get a lot of the world's copper and iron. Another surface method is strip mining. You see this a lot in flatter areas. The idea is to remove these long strips of soil and rock, they call that overburden, to get to the ore underneath. In theory, that overburden is then put back to fill in the trench, but restoring the land is a massive challenge. But what if the ore is way, way down? That's where you get into subsurface methods, like shaft mining. We're talking about digging incredibly deep vertical shafts and then tunneling out sideways to reach the ore. The gold mines in South Africa, for example, can go down over 2 miles. It's just an incredible feat of engineering. Okay, so we've got the ore out of the ground. But we're not done yet, not by a long shot. Now we have to turn that raw rock into pure metal. That's our fourth section: forging modern materials. This is a whole process in itself, usually with 3 main steps. First, you've got to concentrate it, which means crushing the ore and separating out the good stuff. Then you extract the metal, using either smelting, which involves intense heat, or leaching, which uses chemicals. And finally, you refine it to get it to a really high purity. And this is absolutely crucial to understand. All of this processing can have some really serious environmental costs. Smelting, for instance, can release sulfur dioxide into the air, which causes acid rain. And the chemicals used for leaching can contaminate rivers and streams if they're not managed perfectly. So that leads us right into our final section, the big picture stuff, our mineral future. We have to face the fact that these resources aren't going to last forever. And just to put the scale of this into perspective, get a load of this number. The US makes up about 5% of the world's population, right? But it uses around 30% of the world's mineral resources. That's a huge imbalance and a major driver of all this mining activity around the globe. And that really forces us to ask a tough question. Because minerals are formed over geologic time, we're talking millions and millions of years. They're basically non-renewable for us. What we have right now is all we're ever going to get. So the real question is, how long is it all going to last? So what can we do? How do we make what we have last longer? Well, the two biggest things we can do are conservation. That's just using less stuff. And recycling. For example, making an aluminum can from recycled aluminum uses way, way less energy than making one from scratch. And that's where smart policies, things that encourage us to conserve and recycle, become so incredibly important for the future. So, at the end of the day, we're left with this huge question. Our entire modern world is literally built from minerals, but they're finite. They will run out eventually, so what are we going to build our future with? Thinking about that isn't just for geologists, it's something we all need to consider.